right, on number 32, we are looking at two pieces of information here. They have told me that I have the first derivative at -3 equal to 0. By telling me that, they're telling me that I have a critical point there, which means that I have some kind of either maximum or minimum point. So where x is equal to -3, on my graph of f, I have either a maximum or a minimum. They have also told me that the second derivative at -3 is equal to 5. And so by telling me that, they're telling me that the second derivative is a positive. Okay, and I want to know what can I conclude about f using the second derivative test. Okay, well, we've already said that we can tell that it has a maximum or a minimum. By telling me that f double prime is positive, they're telling me that it is concave up. So let's draw a little picture of what this looks like. At -3, I know I either have a maximum or a minimum, and that my graph's going to be concave up. Now this thing can go down as far as I want to. It doesn't matter how far down it is, just so long as I have concave up and that maximum or minimum point right there. And so when you see the picture, you can see that we draw a minimum point right there. So this is telling me the second derivative test shows that we have a local minimum point at x equals -3. Okay, so the graph of f has a minimum point where x is equal to -3. Okay, on 33, they give me a function to work with, and again ask me about the second derivative test. So let's start by taking the function that we're given, which is this one, and finding the second derivative. So the first derivative, when I multiply by 3, gives me 2x squared, and multiply by 2 gives me x. 1/2 and the 2 will cancel out, so just x there, and -15. And the second derivative is going to give me 4x plus 1 plus 0, so just 4x plus 1. Okay, so first I want to know what f double prime is at -3. So they're asking me, what does the second derivative tell us about where x is equal to -3? So let's find out what that is. So 4 times -3 plus 1 is going to give me -12 plus 1, which is -11. All right, so at x equals -3, I have a second derivative that is negative, which means that my graph is going to be concave down. And let's draw a little graph of this. -3 and concave down tells me that we have a local maximum point when the graph of f is at -3. So the graph of f, so f of x, has a local max at x equals, let's say x equals -3, and it asks me to justify my answer, so because the second derivative is negative. And that's plenty of justification right there. So by telling me the second derivative is negative, I know that my graph is concave down. Therefore, I have drawn a local maximum. And finally, on number 34, they've asked me to fill in this chart. So I'm just going to write right here on the worksheet. So let's start by writing down, they want me to write positive, negative, or 0 in my chart. So let's start by just filling in what we know about f. So above the x-axis is going to be positive, and below the x-axis is going to be negative. Okay, so with A, I know that I am positive, and B is negative, and C is back to positive. So that was kind of the easy part of that one. All right, then I want to talk about f prime. So with f prime, when f prime is positive, I know that f is increasing. When f prime is negative, I know that f is decreasing. And when f prime is 0, I know that I have either a maximum or a minimum. Okay, so let's look at A. So at A, the graph of f, which is what's given to me, this is the graph of f, is decreasing, so I know f prime is negative. At B, I have a local minimum, so I know f prime is 0. And at C, the graph of f is increasing, so I know f prime is positive. And finally, f double prime is positive when f is concave up, And f double prime is negative when f is concave down, and f double prime is equal to 0 on an inflection point or a point of inflection. Okay, so at A is a part of this piece right here, so that's going to be concave up, so A is positive. All right, B is a part of this piece right here, so that is also concave up, so that is also going to be positive. And C is a part of this piece over here, which is concave down, and so C, the second derivative, would be negative.